Section 12.4, Heterogeneous Equilibria. Homogeneous and heterogeneous, or homogeneous and heterogeneous equilibria. Homogeneous equilibria involve systems where all the reactants are in the same phase, and heterogeneous equilibria involve more than one phase. Right? So, for example, if you've got calcium carbonate as a solid, right, and it produces calcium oxide and CO2 as a gas, that's heterogeneous. The position of a heterogeneous equilibrium does not depend on the amounts of pure solids or liquids present. Right? So this calcium carbonate over here, we're not going to see that in our equilibrium expression. If we made H2O liquid, we're not going to see that in our equilibrium expression. The concentrations of pure solids and pure liquids do not change during the course of a reaction. Just kind of like when you did that heating curve, and as long as you had some ice in there, you knew the temperature was going to be zero. The concentrations of our pure solids and pure liquids are not going to change. Because their concentrations don't change, solids and liquids are not included in the equilibrium constant expression. So we've got carbon dioxide gas and water liquid giving us H plus aqueous and HCO3 aqueous. Our equilibrium expression is going to still be products over the reactants, but you'll notice that the H2O is missing because we haven't changed the concentration of liquid. All right, so let's look at an example here where I've got two beakers, two bell jars, one with a small amount of carbon on the bottom and the other one with a bigger amount of carbon at the bottom. As our reaction goes forward and we proceed from having CO2 forming CO2 and some carbon, the amount of carbon dioxide is the same. The amount of carbon monoxide is the same at both equilibria. They're at the same temperature. Our value of K is going to be the same. So we're not going to write it as this, where the carbon shows up as a product. So if you think about what is the concentration, how many moles of carbon do I have per liter? Well, if I take a smaller bit, I haven't changed the concentration any, right? It's like if I take a 1 liter of a 1 molar solution and I take 1 drop out of it, the concentration is the same. The amount of moles has changed. The volume has changed a corresponding amount. Our concentration has not changed. And so we're going to rewrite it as this, right, where we're going to have just our carbon dioxide and our carbon monoxide showing up. Our solids do not change their concentration. All right, so let's look at an example. Equilibrium expressions for heterogeneous equilibrium. We'll write the expressions of K and Kp for the following processes. Solid phosphorus pentachloride decomposes to liquid phosphorus, trichloride, and chlorine gas. And B, deep blue solid copper sulfate pentahydrate is heated to drive off water vapor and form solid copper 2 sulfate. I don't know if you guys did this in lab or not, but it's a cute little lab. So for our first one, our balanced chemical equation is phosphorus pentachloride is going to give us phosphorus trichloride and chlorine gas. Our equilibrium expressions are going to be K is going to be equal to the concentration of Cl. Why just Cl? Well, this guy over here is a solid, doesn't show up. This guy over here, the phosphorus trichloride, is a liquid, doesn't show up. So sometimes the only thing you can monitor might be limited. So our concentration of K, our equilibrium K, is going to be equal to our concentration of chlorine. And our Kp is just going to be the pressure of the chlorine gas. In this case, neither the pure solid PCl5 or our pure liquid PCl3 is included in the equilibrium expressions. For our reaction with our copper sulfate, we're going to take our hydrated form here. We'll drive off the water. In this case, we've got 2 solids and 1 gas. So our equilibrium expression is just going to be, for Kp, the concentration of H2O raised to the 5th power. And our Kp is going to be the pressure of the H2O raised to the 5th power. Our solids are not going to be included. If you were looking for a delta N, right, what would delta N be?